Hello, everybody. Just about a few words about me. I am energy manager instructor at national level, so I teach other people. I have company which specialized in this field. So I will show you what can be done. A lot of things can be done. It's not active. Okay. We will first start with some very basic stuff. So, like very basic, just look at the voices. You should never underestimate it, because this is one municipality in the north of Slovenia. We have some electricity, high tariff, low tariff. This is every month. So basically, we imported the data just like that. Just if you solve the graph, you can see the high tariff and low tariff is basically the same. So is this okay? No. It's a complete disaster. They threw away like half of their energy. So that building should be inspected, and it was. Let's say you are manager of health center. This one is quite near. And you see this data. What can we say about this data? It is good, it is bad. I don't really know. I only saw this data. But let's take another health center from different parts. We have the same area. So they are basically the same size, the same buildings, the same activity. But just look how different they are. So lesson is here, we need to compare things. Why is this like this? We quickly know that this health center has problems. Okay, let's go one level up. We finish with very basic stuff. Let's go to the real monitoring. So when we know there is something wrong, we can use the monitoring. They are like these little boxes. We just put it there, and I know everything. They're very powerful if you know how to use it. We check like temperature, humidity. We know how the heating system works. We check the CO2. You know how the ventilation is working. I know if somebody opened the window. I know if somebody turned off the light or not. But we must know two other things. If we make ventilation reduction too much, we will impact the quality of life. We don't want to do this. So we measure also volatile organic components, quality of air, and we measure also radiation. So this one has radiation Geiger counter inside. If there is any radioactive gas, we should know about it, because this is important for health. We don't want to impact the health by lowering the energy bills. So how about we took it to the practice? This is one primary school. This is also in the north of Slovenia. It's quite a big one. I put the tensor at Friday. I took it on Monday. You can see I got a flat line. Is this okay? This is like 22 degrees. So I immediately know that there is no reduction. They are heating the very large object, the structure, the Saturdays, the Sundays, the holidays. They did it for like 20 years. Then I called the guy. So, okay, this is not good. You must change this. So he did change. I monitored him real time. I saw this. Called it again. Oh, this is not good enough. You must improve even better than that. So energy monitoring is a quite powerful tool, but we use it in real time. Okay, let's go one level up. We can do even better than that. I also make industry level energy monitoring systems. They are quite very sophisticated. There is one standard in the back. basically, you know everything what is happening in the factory by blink. Just like that. Just press the button and you have everything. We won't go in technical details, like we monitor harmonics, steady state disturbances, and many other different events. What is interesting, we do it very, very fast. We do it like in milliseconds. This is faster than you can blink. So if we now we know how much we use and exactly when, even faster when you blink. But it is good enough. Well, let's take it another level up now. When something is wrong, we also should know why. This is very important. So we use some tests on building certifications. They are also based on standards. They're like they are ventilators, and we overpressure the building. So we know how much we lose. With thermal camera, we see every detail. But here, this image alone, there are 17 errors. This is new window in kindergarten. If I go to inspect your house, if you have less than 50 errors, then I could say you are above average. This equipment is very, very precise. So imagine yourself buying a new car and you have like 50 errors in your car. Well, if I wouldn't buy it. So this is even more expensive. You must have very, very good construction practice to do this. So in general, we check for errors in construction, electric installation, and windows, and other things. How is this done in practice? This is like one sports center right here in nearby town. We check the pressures. Well, we should measure less than 7,050. So this is our target for this kind of building. We measured like over 60,000, more than 10 times more. So this is engineering disaster. It's completely unacceptable. I sent one guy out, he took out the panels. When we checked what is happening, it was criminal how they build this building. So it really must be done properly. The repair cost was quite high. They couldn't get the temperature in this building any higher than 16 degrees because they all lose air through the roof. They ever come here, you just go over in outlet. And this was it. Nobody figured out this for 10 years. But that is important is the details. Here is like a wooden structure and brick structure. The same thing, but it is done differently. There are different kinds of problems when you are doing something like this. So must be remembered, a lot of depends on what you are doing. You shouldn't do something like this. This is clearly a very bad one. For example, if you have electrical tubes, look at this one. They are together. They shouldn't be. It must be separated. If I saw this, they must repair it. Same thing for some other details. This guy, this was some house in Ljubljana, capital. He takes all the things. Okay, but completely forget it. When I saw this, I said, what are you doing? This is not the way you do this thing. It's just not acceptable to do all the details here and forget a lot of things below just about the concrete slabs. This is like some windows. They are good windows, but they are installed incorrectly. In this section, there are some pointers of errors. All the things you see here, they have to be repaired. Okay, what if we go one level up for now? So, well, what about if you have a well-error complexes, industrial scales, the cities. Okay. Views cross. I was the first in Slovenia to develop a drone with thermal camera, like 10 years ago. It was quite history now. If we saw one power plant, every dot is a problem. You can see what happens. Well, this heats up so much that it can melt. It is dangerous. You don't want that electrical installation is melting at your house, your power plant. It is just not recommendable. It can cause not just production loss, but also fire hazard. So the buildings and power plants, they are inspected. But if I took this technology and to the whole city, yes, we do the whole city. It is a different kind of approach. Mostly we do this with district heating, but a lot of times we can clearly see the public buildings on these maps. These maps are basically maps of money. So this is easily understandable. Every bit of heat is basically money that is evaporating out. We mostly do this with industrial complexes, but also for district things. These are two pictures. This is one of the worst, but they were both taken in this city. For example, this is one two-story building, and there is quite high leakage. Well, you don't need to worry about the snow here. You don't need to do anything. This picture is right near the melamine plant. So this was repaired shortly after this picture. So this is not current status, but you can see what can happen. So we are basically very vigilant to find such spot. It can be associated with very high cost. So this is very short. Hope you enjoyed. So I invite you now to coffee.